Welcome back. So let's look at this two-tailed hypothesis test for the high school math and science and what their parents think about it. So the null hypothesis is that the current population proportion is still the same as it was, when was that, in 1994. The alternate hypothesis, the one that's being investigated, is whether the proportion is now different. We have a point estimate using a current sample. And in that point estimate, 256 out of 800 had the characteristic we're investigating, which is feeling like not enough math and science is taught to their high school children. And that works out to be 0.32. Let's see, the mean is the population proportion given in the null hypothesis. The standard deviation is that mean, 1 minus the mean, over sample size, all under the square root. Doing that on a calculator, we get 0.0177. Okay, so that allows us to compute our test statistic. Which is z, so 0.32, our point estimate, minus the mean, 0.52, divided by the standard deviation, sigma. So doing that on a calculator, you get negative 11.32. So this is just the formula for the z-score. Okay, so we took our point estimate, converted it into a z-score. Now we're interested in the probability of having a point estimate that was this far off the mean. Okay, so this was, you know, there's a certain difference between the point estimate and our assumed mean. We want to know how likely it is that we'd get a point estimate that far off. We've converted it to a z-score, and we're going to use the table. So that's our z's. We're going to use the table to figure out the total area out here, which again represents the possibility of getting a point estimate that's this far or further away from the mean. Okay, so let's see. Negative 11.32. So, and again, we'll let me just go ahead and put some labels down here for what we're looking up. So our p-value, that's the probability that z is less than negative 11.32 plus the probability that z is greater than positive 11.32. We need just one of those areas, and then we'll double it. Since the z table gives you areas to the left, I'm going to go ahead and get that area since it's one to the left. Probability that z is less than negative 11.32. Okay, now on the table, 11.32, negative 11.32. Well, gosh, the table only gives us z-values down to negative 3.4. So it's giving us z-values to a certain point, but we're interested in z-values to the left of that, right? So again, the table only gives you a z-value, say to, to negative 3 something, and we're all the way over here. How do we deal with that? Well, let's take the area to the left of the leftmost z-value that the table will give us. So the leftmost z-value that the table will give us is negative 3.49, and the area to the left of that is 0.0002. So our area is less than 0.0002. All right, let me try to convince you of that, just in case you're not already. Okay, so let me make a bigger picture here. So I want the area to the left of negative 11.32. Table won't give it to me. What the table will give me is the area to the left of 3.49, and that's the leftmost z-value that the table will give me. But what it does tell me is that the total area to the left of that is 0.0002. Okay, area to the left of negative 3.49, the table tells me is 0.0002. Well, then that means that the area I'm interested in, which is actually only this much of it, right, up to there, that's got to be less than the 0.0002 area that's to the left of there. Okay, so in doing this computation, this probability is actually less than, the probability I'm looking for is actually less than the probability I wrote down. But notice that means that what we're getting, we're totally safe in saying that the probability is less than 0.0008. Notice that is certainly less than the level of significance, 0.05. Okay, this is our alpha. This is our estimate of our p-value. And our p-value is actually less than that. We don't know how much less, but it doesn't matter, because to make our decision, all we need to notice is that the p-value is less than the level of significance. So that's when we reject the null hypothesis. Okay, so p-value less than level of significance, reject H naught, and we conclude then that there is sufficient evidence to conclude that the proportion of parents who feel children are not being taught enough math and science in high school is different today. So we're stating this in terms of the alternate hypothesis, is different today than in 1994. Okay, I hope that went okay for you. I'll leave you there, and we'll come back and do something different in the next video. See you then.